Hi and welcome back. We're doing projectile motion problems dealing with general launch angle. And what we mean by that is that it's any launch angle other than 0 degrees. It's not moving out horizontally and then being pulled down because of gravity, but it's actually being shot up, or you could even say shot downwards at an angle, any angle other than 0 degrees. Okay, so we have a dolphin jumping out of the water here, and he's jumping out, or he or she is jumping out towards the trainer, who is 4.1 meters above. And the dolphin is angled in such a way that it's aiming towards the ball. But as soon as the dolphin leaves the water, the trainer drops the ball, and the dolphin hits the ball in midair. This actually does work this way, and part of this problem is to prove that it does. So the dolphin starts out by aiming at the trainer, but as soon as the dolphin leaves the water and the trainer drops the ball, the dolphin takes a parabolic path, the ball drops straight down, and our job is to prove that they meet in midair. And this right here, this is really what we're shooting for. We want to find the final Y position of the dolphin and the final Y position of the ball. Now the dolphin is moving out horizontally, and it's going to be covering this 5.5 meters. The ball is simply moving straight down, but we'll be able to prove that it all works out. Now one thing we also need to assume is this right here, that the time the dolphin spends in the air is the same amount of time that the ball spends in the air. Alright, so the dolphin is moving out horizontally and kind of at an angle. The ball is dropping straight down, but they both have the same amount of time to fall. That's good to know. That's convenient for us, because whatever we don't know in the Y direction, we can solve for in the X direction and then apply the time in the X direction to the Y. One more thing we need to do before we can actually start is find this angle right here, because we're told that the dolphin is jumping out with a velocity of 12 meters per second, but that's at this angle right here. Well, we want to find this angle theta, and you know what, I'm just using too much black in there. Let's change to a different color. Let's make that oh, I don't know, purple, alright, or violet or something like that. Alright, that's our theta, and we want to solve for theta. So we can say that theta is the inverse tangent of the x component, or sorry, of the y component over the x component, right? That's 4.1 meters, or just simply 4.1. We could say 4.1 divided by the x component, 5.5 meters, because that's how far the dolphin is away from the ball. So this angle right here, theta, this is going to come out to be, what is theta going to be? 36.7 degrees. 36.7. That's going to be helpful. We're going to need to know that, because we're going to need to find the x and y components of this initial velocity. So this initial velocity is in fact 12 meters per second. Okay, but we don't really care so much about that. We care about, what we care about is the x and y component. So let's just write this down. Initial velocity, before I even do that, we're solving for the dolphin's time first. Okay, or just for the dolphin. Alright, the initial velocity of the dolphin is 12 meters per second at some angle, at this angle 36.7 degrees. Okay, in fact, well, why don't I just write that at 36.7 degrees. And by the way, I usually round off degrees, but this one I kept in because we want to be as exact as possible. So we should be able to say then that the x component, initial velocity of the x in the x direction, would be 12 meters per second times a cosine of 36.7 degrees. So 12 meters per second cosine 36.7 degrees. That'll give us an x component of the initial velocity of 9.6 meters per second. Alright, let's write down all the other stuff we know in the x direction. We know that the x displacement, that is for the dolphin to go from here to where the ball is, that's 5.5 meters. Okay, is there any acceleration? No, there's not, because it's not moving any faster or slower in the x direction. It's maintaining actually a constant velocity in the x direction, unlike the y, but we'll get to that in just a second. Alright, and what we want to find is the amount of time it takes, we'll say, in the x direction. In the x or the y, it doesn't really matter, but we want to solve for time using what we know in the x. I'm going to solve for the amount of time for the Dolphin to go from here to here in the x direction. That's the amount of time it has to go up and come back down to where the ball is, and then we'll compare that to how long it takes the ball to fall to that point. Okay, so this we do not know, but we can solve for it. We know that our displacement is initial velocity times time plus 1/2 times acceleration times time squared, and fortunately for us, this goes away because acceleration is 0. So we can say simply that our time, in using components in the x direction, is going to be our x displacement divided by our initial velocity in the x direction. Alright, so our x displacement is 5.5 meters. Our initial velocity in the x direction, that's 9.6 meters per second. Remember, we had to figure that out earlier on. So what does that come out to? For me, that comes out to 0.57 seconds. Okay, let's put a dotted line box around that, because that's going to be important. That's how much time the Dolphin is moving horizontally, which also is the amount of time that the Dolphin can move vertically and reach that height wherever the ball will be. Okay, so let's go back to our y direction now. I'm going to pick a light blue for y. Alright, our initial velocity in the y direction. That's really kind of electric blue, isn't it? What's the initial velocity in the y direction? That would be this component right here, right? Initial velocity in the y. Earlier on, we found the initial velocity in the x direction. We found that was 9.6, right? X. We want to find it in the y direction now. Let's get that same color again. Alright, so that would be our velocity of the Dolphin, that is the full velocity, 12 meters per second, times the sine of the angle, which is 36.7 degrees. Alright, this gives us the y component of the Dolphin's velocity, because we know the velocity and angle. We can find the y component by doing this. So 12 sine 36.7, that gives me 7.2 meters per second. So that's how fast it's moving in the y direction. What's the displacement in the y direction for the Dolphin? That's what we want to find. We want to compare this and find out, okay, in this amount of time, how high or where is it when it goes up and comes back down? Hopefully it's the same as where the ball is. So that's what we're solving for in the y direction. Time for the y direction. That's the same thing as time in the x direction, and that's going to be 0.57 seconds. Okay, the Dolphin has that much time to move horizontally, which means it has that much time to move vertically up and down. And we also know finally that the acceleration in the y direction is negative 9.81 meters per second squared. That's acceleration due to gravity. Okay, so let's see if we can solve now for where the Dolphin actually is in the y direction after this amount of time. Okay, so our displacement in the y direction, in fact, you know what, I'm going to move it down here, save us some space. Displacement in the y direction, that's initial velocity in the y direction times time, plus 1/2 times acceleration in the y direction times time squared. Alright, so initial velocity in the y direction, that's 7.2 meters per second times how much time? 0.57 seconds, plus 1/2 times our acceleration in the y. We all know that's negative 9.81. meters per second squared. I'm really not saving much space over here, am I? Times our time squared, 0.57 seconds squared. All right, let's just kind of see if I can move that over a little more. What am I doing here? Oh, I'm gonna do this. That's a little better. Okay, what do we get for our displacement in the y direction of the Dolphin? Dolphin. I get that the Dolphin is 2.51 meters in displacement. So if the bottom level, that is the initial position of the Dolphin, is 0, it is moved up to a height of 2.51 meters. Okay, so hopefully the ball dropping down from the top of the diving board, or whatever that thing is, hopefully the ball is at 2.51 meters, since it's falling straight down to where the Dolphin will be, and it's falling with the same amount of time. So let's solve now for the ball. Now the ball I'm going to write in red because I drew it in red right here. So for the ball, ooh, this is going to be kind of messy. You know what? Let me see if I can do a little bit of shuffling here. Take this guy, take this whole mess, and just do that with it. Try to save a little more space. Try to keep it a little bit neater. All right. So for the ball, what's the initial velocity in the y direction? By the way, this is all going to be written in blue because the ball is only falling in the y direction. All right. So where's my there we go. Let's pick that blue again. And initial velocity in the y direction is 0 meters per second, right? Because it's not falling at all as soon as the person drops the ball. It starts moving after that, but initially it's 0. What else is true? Oh, we know the acceleration in the y direction. That's negative 9.81 meters per second squared. That's helpful. We know that the time for the ball to fall straight down in the y direction is the same amount of time that the Dolphin has to move horizontally and get to that point. That's 0.57 seconds. And we want to find the final velocity, the final position, y final, of the ball. We can also write, by the way, that the y initial of the ball, that is the initial position of the ball, is 4.10 meters up. 4.10 meters in height, or above the water. Okay, so we can solve for our displacement, and then hopefully the final position of the ball will be where it was, or where the Dolphin will be. All right, well, we have initial velocity, acceleration, we got time. Can we solve for displacement? Yes, we can. That's initial velocity in the y direction times time, plus 1/2 times acceleration in the y direction times time squared. That is for the ball. Okay? So, one thing that makes this easier for us is that this goes away, right? Because the initial velocity is 0. That's helpful. So really, our displacement in the y direction is 1/2 times negative 9.81 meters per second squared times our time, 0.57 seconds squared. All right, so let's find our displacement of the y, and then use it in conjunction with the initial position of the y to find the final position of the ball in the y direction. So 1/2 times negative 9.81 times 0.577 seconds squared, I get oh darn it, you know what I did? I accounted for the well, let me just calculate this out. 0.5 times negative 9.81 times 0.57 squared. I get negative 1.59 meters. I did it a little bit differently, but that's okay. All right, so it's displaced downwards. Delta y equals negative 1.59 meters up here. So if it starts at 4.10, then we can say the final position of the ball equals the initial position plus the change. Or you might remember we said before that the change is always the final minus the initial. Well, we just added the initial over to this side. Okay, so that would be 4.10 meters plus negative 1.59 meters, and that gives me 2.51 meters. That's where the ball is at that time right there. And conveniently enough, it's also where the Dolphin is at that time right there. So it works. So the Dolphin is aiming at the ball, and the ball is dropped at the exact same time. It will meet the ball in midair. So we've just proved that the Dolphin and the ball will meet at exactly the same spot. So again, hopefully that helps. Let me know in class if you have any questions. Thanks for watching.